All right, Stephen. This week, Meta announced at the RISC-V summit that they're all in on this new chip architecture. They've been looking at integrating RISC-V into their lineup for at least the last 4 years, and all of their efforts seem to be going well according to the interviews that I've seen. Now, you're probably wondering, does this mean that they're going to ditch all of their CPUs for these ARM-based processors or RISC-based processors? And the answer is no, because they're using them in very specific applications like video transcoders, inference accelerators, and AI training systems. The goal is to move any workload that needs to be accelerated onto a RISC-V based system so that the CPUs aren't being eaten up by all of these, specific workloads. Stephen, why would Meta be ignoring the current state where everyone's using GPUs for everything, not to mention x86 and ARM, and jumping right into RISC-V?
I think the answer is because it works. I'm very excited about what RISC-V is, what the potential of RISC-V is, but of course, the proof is in the pudding, and this is some of the best pudding announcements I've seen in a long time. So just to reiterate here, at the RISC-V Summit, Meta announced that they have built a scalable video processor, MSVP, built on the RISC-V instruction set, but with custom instructions that they have added to allow much more high-performance transcoding of video. And in fact, not only is this in production, it is handling every single video that's being uploaded to Facebook, Messenger, and Instagram as we speak. They've also announced that this optimized processor replaced 85% of the CPUs that were formerly doing that. So in other words, they're now down to a footprint only 15% of the size of the previous one. This seems credible to me simply because it is an optimized processor to do a specific task, the specific task being transcoding video into Meta's preferred format. That is the ideal use case for something like RISC-V. You have a hyperscaler with lots of resources and lots of needs, very predictable data, and of course they can make an accelerator that does just this one thing, and it does it very, very well. I think that what we're going to see increasingly is companies like Meta are going to be adopting custom processors to do things like this, high volume tasks that can be accelerated in silicon. And they're going to be using RISC-V to do that because ARM doesn't let companies, unless they have the very special super elite diamond status license, ARM doesn't let them change the inner functions of the chip. RISC-V you can, and Meta was able to put together their own special chip, and it works great. I also think that this is a huge vote of confidence for the RISC-V architecture overall, and I think that we're going to see a lot more coming out of this. In fact, I would not be at all surprised if there are future announcements from companies like Meta that they're going to be, for example, accelerating AI workloads with special custom instruction sets on RISC-V. That would be another great low-hanging fruit. Certainly more and more transcoding processors are going to be using this thing. And frankly, I wouldn't be surprised at all if we find out in the future that certain serverless applications are running on specialized RISC-V servers in the cloud. That would make a lot of sense. If you're interested in this topic, I actually recorded at AWS reInvent a Gestalt IT tech talk with a friend of the show, Daniel Newman from the 6.5. And we're going to be publishing that shortly, so you'll be able to hear the thoughts of me and of Daniel on the evolution of the data center and the cloud from CPU and GPU and x86 to ARM and potentially to RISC-V.